Welcome back, guys. So now we are going to, continue with our yeah Cairo coding. So far, what we have done, just to recap, is get a basic overview of get a basic overview of what we are doing. What is a blockchain, how and what role zero knowledge proofs in this scalability things for the blockchain, and what is validity rollup, and what Cairo is, and how we can start with this hello world of Cairo programs. So now what we are going to do is go to the Cairo website, Cairo programming language website, and start with the very basic. Okay, Cairo programming language. Okay. Forward in 2020, Starknet released Cairo 0, a Turing complete programming language supporting verifiable computation. Cairo started as an assembly language and gradually became more expressive. The learning curve was initially steep, as Cairo 0.x was low-level language that did not entirely abstract the underlying cryptographic primitives and required to build a proof for the execution of a program. With the release of Cairo 1, the developer experience has considerably improved, and abstracting away the underlying immutable memory model of the Cairo architecture where possible. Strongly inspired by Rust, Cairo 1 has been built to help you create provable programs without specific knowledge of its underlying architecture so that you can focus on the program itself, increasing the overall security of Cairo programs. Powered by Rust VM, and the powered by Rust VM, the execution of Cairo programs is now blazingly fast, allowing you to build an extensive test suite without compromising on performance. I guess instead of the Rust VM, it should be Cairo VM. I guess blockchain developers that want to blockchain developers that want to deploy contracts on Starknet will use the Cairo programming language to code their smart contracts. This allows this allows the Starknet yeah this allows the Starknet OS to generate execution traces for transactions to be proved by a prover, which is then verified on Ethereum L1 prior to updating the state root of Starknet. Blockchain developers that want to deploy contracts on Starknet will use the Cairo programming language to code their smart contracts. This allows the Starknet OS to generate execution traces for transactions to be proved by a prover, which is then verified on Ethereum L1 prior to updating the state root of Starknet. However, Cairo is not only for blockchain developers. As a general purpose programming language, it can be used for any computation that would benefit from being proved on one computer and verified on another machine with lower hardware requirements. This book is designed for developers with a basic understanding of programming concepts. It is a friendly and approachable text intended to help you level up your knowledge of Cairo, but also helps you develop your programming skills in general. To dive in and get ready to learn all there is to know about the Cairo. Let's read it all over again. I guess it's better to read this. Okay. So in 2020, Starkware released Cairo 0, a Turing complete programming language supporting verifiable computation. Okay. Cairo started as an assembly language and gradually became more expressive. The learning curve was initially steep, as Cairo 0.x was a low level language that did not entirely abstract the underlying cryptographic primitives required to build a proof for the execution of a program. With the release of Cairo 1, the developer experience has considerably improved, abstracting away the underlying immutable memory model of the Cairo architecture where possible. Strongly inspired by Rust, Cairo 1 has been built to help you create provable programs without a specific knowledge of its underlying architecture so that you can focus on the program itself, increasing the overall security of Cairo programs. Powered by a Rust VM, the execution of Cairo programs is now blazingly fast, allowing you to build an extensive test suite without compromising on performance. Blockchain developers that want to deploy contracts on Starknet will use the Cairo programming language to code their smart contracts. This allows the Starknet OS to generate execution traces for transactions to be proved by a prover, which is verified on Ethereum L1 prior to updating the state root of Starknet. However, Cairo is not only for blockchain developers. As a general purpose programming language, it can be used for any computation that would benefit from being proved on one computer and verified on another machines with lower hardware requirements. This book is designed for developers with the basic understanding of programming concepts. It is a friendly and approachable text intended to help you level up your knowledge of Cairo, but also help you develop your programming skills in general. So dive in, get ready to learn all there is to know about Cairo. Okay, installation. Okay, what is Cairo? Cairo is a programming language designed for a virtual CPU of the same name. The unique aspect of this processor is that it was not created for the physical constraints of our world, but for cryptographic ones, making it capable of efficiently proving the execution of any program running on it. This means that you can perform time consuming operations on a machine you don't trust and check the result very quickly on a cheaper machine. While Cairo 0 used to be directly compiled to Chasm or Cairo CPU assembly, Cairo 1 is a more high level language. It first compiles to Sierra, an intermediate representation of Cairo, which will compile later on to the safe subset of Chasm. So I guess the main, take point that needs to be taken from is this Cairo 1 first compiles to Sierra, which is an intermediate representation of Cairo, which later compiles down to a safe subset of Chasm. So we will note it down. Okay, so Cairo program returns in written written in Cairo 1 first gets first gets compiled to Sierra, which is an intermediate representation of Cairo. Then it gets Cairo. Then it gets compiled to safe subset of Chasm. Right? Then it gets compiled down to which will compile later down to a safe subset of Chasm, which will later compiles down to safe subset of Chasm. What is Chasm? Chasm is a Cairo assembly. Cairo assembly. Cairo CPU assembly. Okay. So that is, I think, very important point. Okay. So Cairo is a programming language designed for a virtual CPU of the same name. The unique aspect of this processor is that it was not created for the physical constraint of our world, but for cryptographic ones, making it capable of efficiently proving the execution of any program running on it. This means that you can perform time consuming operations on a machine you don't trust and check that result very quickly on a cheaper machine. While Cairo 0 used to be directly compiled to Chasm, thus Cairo CPU assembly, Cairo 1 is a more higher level language. It first compiles to Sierra, an intermediate representation of Cairo, which will compile later down to a safe subset of Chasm. The point of Sierra is to ensure your Chasm will always be provable, even when the computation fails. So even if like there is some issue, let's say loop condition, right? Even then the program will be provable. If I can, yeah, I guess that will be the case. Okay, what can you do with it? Cairo allows you to compute trustworthy values on untrusted machine. One major use case is Starknet, a solution to Ethereum scaling. Ethereum is a decentralized blockchain platform that enables the Ethereum is a decentralized blockchain platform that enables the creation of decentralized applications where every interaction between a user and a DApp is verified by all the participants. Starknet is a layer 2 built on top of Ethereum. Instead of having all the participants of the network to verify all user interactions, only one node, called the prover, executes the programs and generates proofs that the computations were done correctly. These proofs are then verified by an Ethereum smart contract, requiring significantly less computational power compared to executing the interactions themselves. This approach allows for increased throughput and reduced transaction cost while preserving Ethereum security. So this is basically the idea. So Cairo allows you to compute trustworthy values on untrusted machines. One major use case is Starknet, a solution to Ethereum scaling. Ethereum is a decentralized blockchain platform that enables the creation of decentralized applications where every single interaction between a user and a decentralized app is verified by all the participants. Starknet is a layer 2 built on top of Ethereum. Instead of having all the participants of the network to verify all user interactions, only one node, called the prover, executes the programs and generates proofs that the computations were done correctly. These proofs are then verified by an Ethereum smart contracts, requiring significantly less computational power compared to executing the interactions themselves. This approach allows for increased throughput and reduced transaction costs while preserving Ethereum security. Okay, what are the differences between other programming languages? Cairo is quite different from traditional programming languages, especially when it comes to overhead costs and its primary advantages. Your program can be executed in two different ways. When executed by the prover, it is similar to any other language because Cairo is a virtualized and because operations were not specifically designed for maximum efficiency. This can lead to some performance overhead, but it is not the most relevant part to optimize. When the proof is verified by a verifier, it is a bit different. This has to be as cheap as possible since it could potentially be verified on many very small machines. Fortunately, verifying is faster than computing, and Cairo has some unique advantages to improve it even more. A notable one is non-determinism. This is a topic you will cover in more detail later in this book, but the idea is that you can theoretically use a different algorithm for verifying than for computing. Currently, writing custom non-deterministic code is not supported for the developers, but the standard library leverages non-determinism for improved performance. For example, sorting an array in Cairo costs the same price as copying it because the verifier doesn't sort this array. It just checks that array is sorted, which is cheaper. Another aspect that sets the language apart is its memory model. In Cairo, memory access is immutable, meaning that once a value is written to memory, it cannot be changed. Cairo 1 provides abstractions that helps developers with these constraints, but it does not fully simulate mutability. Therefore, developers must think carefully about how they manage memory and data structures their programs in their programs to optimize. Okay. Mm, okay, let's read a bit about this Cairo CPU architecture. I want to read a bit about the Cairo CPU architecture. Okay, uh, Cairo, a Turing-complete star-friendly CPU architecture. Proof systems allow one party to prove to another party that a certain statement is true. Most existing practical proof systems require that the statement will be represented in terms of polynomial equations over a finite field. This makes the process of representing a statement that one wishes to prove or verify rather complicated, as this process requires a new set of equations for each statement. Various approaches to deal with this problem has been proposed. We present Cairo. a practically efficient, Turing complete, Stark friendly CPU architecture. We describe a single set of polynomial equations for the statement that the execution of a program on this architecture is valid. Given a statement one wishes to prove, Cairo allows writing a program that describes that statement instead of writing a set of polynomial equations. So basically, I guess the idea I can, take is, so there is this concept of prover versus verifier and snarks versus Stark, right? Uh, so I mean, snark is what is like snark is or non-argumentative knowledge, succinct non-interactive argumentative knowledge, and Stark is succinct, uh, transactionable, interactive, argumentative knowledge is there, but okay. We'll come to Snark versus Stark. But I guess the good point here is what is the difference between Snark and Stark in zero knowledge. Our new friend, the Bard. Okay. Snarks and Starks are both types of zero knowledge proofs, which allows users to prove that they know something without revealing any of the underlying information. However, there are some key differences between the two technologies. Snarks, zero knowledge, succinct, non-interactive argument of knowledge are typically faster to generate proofs than Starks, but they require a trusted set of phase. This means that a group of participants must agree on a set of parameters before the snarks can be used. If the trusted set of parameters are compromised, then the snark can be used to generate false proofs. Stark zero knowledge is scalable, transparent argument of knowledge. Does not require a trusted setup. This makes them even more secure than snarks, but it also means that they are slower to generate proofs and can have large proof size. So yeah, the main difference is between the trusted setup, like the alio which you just snark, they requires a trusted setup, like exchanging some secret keys, and once those keys are compromised, you can generate false proof. So Kairos, now let's go to the getting started part. Okay, installation, we are also done, already done with this installation. We need scrap and rust. Hello world, creating a project directory, creating a project with scrap, toml. Okay, and print statement we have already done. Anatomy of a Cairo program. Okay, running tests, Starknet support. Yeah, so that is one thing. Like, if you want to develop the Starknet contracts with this project, we have to add the target Starknet contract, section. But I guess this is for very later steps, so we don't need to worry about these right now. Common programming languages. This chapter covers the concepts that appears in almost every programming language and how they work in Cairo. Many programming languages have much in common at their core. None of the concepts presented here. ठीक है. Okay. Specifically, okay. Variables and mutability. I'm not going to go through them because these concepts are, you know, I have, like, first of all, I have already done the practice of those concepts, for my repository, and also anybody who knows, who are familiar with the, any of the other programming languages, these concepts more or less remain the same, like how to declare variables, how mutating a variable works, and different sort of data types. One important data type that is here is the felt type. uh, so felt type is basically a field element, and in Cairo, if you don't specify the type of a variable or an argument, its type defaults to a field element. In the context of Cairo, we say a field element, we mean an integer range between 0 to p, where p is a very large prime number currently equal to 2 to the power 251 plus 17 into 2 to the power 192 plus 1. When adding a subtracting multiple, these results fall outside the, if the results fall outside the range of the an overflow occur, an appropriate model multiple of p is added or subtracted to bring the result back into the within the range. The result is computed modulo p. Integer types are there. The felt type is fundamental type that serves as the basis for creating all the types in the whole library. However, it is highly recommended for the programmers to use the integer types. Okay, numeric operations is there, Boolean types, short string. Cairo doesn't have a native type for strings, but you can store characters forming what we call a short string inside felt to 52. A short string has a max length of 31 characters. This is to ensure that it can fit in a single field element. Typecasting is there. So Cairo doesn't have a native string type, which is very interesting, right? Functions are there. Uh, I mean, more or less the same thing, similar to the Rust. Comments and control flows are there, if else, if expressions and things, Uh, arrays and dictionaries are there. Like I've already done the array exercise, but we'll start with the dictionary. Okay. So, okay. 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 Cairo provides dictionaries. Uh, dictionaries. Cairo provides in its core library a dictionary like type file to 52 dict data type represents Cairo provides in its core library a dictionary like data type. The file 252 dict data type represents a collection of key value pairs where each key is unique and associated with a corresponding value. This type of data structure is known differently across different programming languages such as maps, hash tables, associative arrays, and many others. The felt 252 dictionary type is useful when you want to organize your data in a certain way for which using an array and indexing doesn't suffice. Cairo dictionaries also allows the programmer to easily simulate the existence of mutable memory when there is none. So I have done this particular part. Okay, dictionaries underneath. It uses entries, squashing dictionaries, more entry and finalize, and then this custom get dictionaries types are not supported natively. Okay. Okay. Nullable from box. I mean, I have not used this thing, but okay, we can come back to this later. tp dot get user. Hmm. Okay. Okay. Dictionaries of types not supported natively. Dictionaries of types not supported natively. One restriction of L 252 dictionary that we one restriction of L 252 dictionary type that we haven't talked about is the trait of L 252 dict value. This traits define the zero default method, which is the one that gets called when a value does not exist in the dictionary. Okay. This is implemented by some common data types such as most unsigned integers, bool and pel to 52. But it is not implemented for more complex types such as arrays, structs, and other types from the core library. Okay. Okay. This means that making a dictionary of types not natively supported is not a straightforward types, because you would need to write a couple of trait implementations in order to make the data type a valid dictionary value type. To compensate this, we can wrap your type inside a nullable. Okay. Nullable is a smart pointer type that can either point to a value or be null in the absence of value. Okay. It's a smart pointer, like a box and ref count in the Rust. It is usually used in object-oriented programming language when a reference doesn't point anywhere. The difference with option is that the wrapped value is stored inside a box type data type, and box type data inspired by Rust allow us to allocate a new memory segment for our type. and access this segment using a pointer that can only be manipulated in one place at a time. Okay, so it is saying that dictionary type fell to 52 dict implements the trait have a trait fell to 52 dict value, and this trait has a method zero default. Okay, this method got called when a value does not exist in the dictionary. It is implemented for some common data types like bool fell to 52, but it is not implemented for more complex types such as arrays, structs, and other types of from the core library. This means that making a dictionary of type not natively supported is not a straightforward task, because you would need to write a couple of trait implementations in order to make the data type a valid dictionary type. To compensate this, you can wrap your type inside a nullable type. Now, what is nullable? Nullable is a smart pointer that can either point to a value or be null in the absence of value. It is usually used in object-oriented programming language when a reference doesn't point anywhere. The difference with option is that the wrapped value is stored inside a box data type. So box is sort of a smart pointer in Rust. Box type inspired by Rust allows us to allocate new memory segment for our type and access this segment using a pointer that can only be manipulated in one place at a time. Let's show using an example. We'll try to store a span file to 52 inside a dictionary. A span is an array again, sort of a snapshot of an array. For that we will use nullable type and box type also. We are storing a span type, not an array type, because the latter does not implement the copy trait which is required for reading from a dictionary. Okay. 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 D dot insert. Nullable from box. In this code snippet, the first thing we did was to create a new dictionary D. We did want to hold a nullable span. After that, we created an array, filled it with values. Okay. Okay. The last step is inserting an array as an span. Last step is inserting an array. Straight new array span directly. We wrapped an array inside the box using a method from the box straight. We wrapped the box inside the label. When the dictionary is inside element, we want to get it. We want to follow the same steps but in the reverse order. Value dot d dot get span match nullable. Okay. From nullable result null. Okay. So this is how we basically is doing it. Okay. So let's write this thing. Actually, I'm going to write this thing first on my paper. That's a very good habit. Then we are going to write this and execute this. Okay. Use dictionary file to 52 dictionary. Right. Okay. Use nullable, or maybe I can directly open this on my second screen, and but in any case I want to write the thing on my own. Okay, so let's see. Okay. Okay, so collections array, let's use the 04 underscore 04 dictionaries dot Cairo. Okay, okay. Use dict felt 252 dictionary trait. Okay, use nullable. Let me first, import this module. And, use let's go 04 dictionaries. Why it is not coming in autocomplete? DICD ARIS dot. Okay, mod. Sorry, it will be mod. Okay, now use nullable from box match nullable from nullable result. Okay, now fn main, let mute d. So if I want to basically add something to it or append anything into it, I have to keep this as a mutable, and the type will be felt to 52 dict 52 dictionary. The values, the key type is always field element, so the values will always be nullable. Sorry, the values type is nullable. Span is array snapshot felt 252. Okay, okay. Default so instead of this, let's use the dictionary nullable example. Okay, let's say print nullable. Sorry, this is not the syntax. Dictionary label dot print. Okay, okay, now let's try to use this. I'm going to comment everything and use okay. Now finally the autocomplete is in action. Let's clear this. Print trait is not fine. That's true. We haven't imported the print. Debug print trait. Okay, let's see now. Okay, missing token semicolon. Where it is this missing token semicolon? Lib Cairo. Okay, in lib. Okay, we are missing the semicolon here. Okay, now let's run this. Okay, we are able to see the text. Nice. Now I'm going to comment this. So we have created a dictionary. Okay, let's create a mutable array. Mutable array is equals to array trait new. array traits, we don't need to import the array trait. It is, I think, already available in the global scope, or in more technical term, prelude. Okay, the good thing is, we can enter string as well, because in Cairo, Cairo only supports short strings, which is also a sort of a field element. So I'm going to just, yeah. So let's see, d dot insert. We want to insert at key 0, nullable from box. Okay, box trait, new, a dot span. Okay, let value equals to d dot get 0. Okay, let span equals to match nullable well. Okay, from nullable result, not null. Panic with felt 252, no value found. No value found from nullable result, not null. Value dot unbox, val dot unbox. Okay, okay, let's try to print the let first element equals to n dot at 0, and let's try to print the first element dot print. So it should print my name. Okay, okay, I see. We can also do the assertion. We can also do the assertion. 0 Satyam, expecting Satyam, assert and dot at 1 Shivam, expecting Shivam, assert Raja, expecting Raja. Okay, let's see, clear this. Okay, so if I change it, let's see, it should fail. Assertion fail. See, this assertion failed. So yeah, so that is about the example of dictionary, I guess. And yeah, let's see what else to be done here. Dictionaries as struct members. Defining dictionaries as struct members is possible in Cairo. Defining dictionaries as struct members is possible in Cairo, but correctly interacting with them may not be entirely seamless. Let's try implementing a custom user database that will let's try implementing a custom user database that will allow us to add users and query them. We will need to define a struct. We will need to define a struct Okay, to represent a new type and trait to define its functionality. Okay, so our new type user database to represent a database of users. It's generic over the balances of the users, giving major flexibility. Giving major flexibility whoever uses our data type. Its two members are users amount. The number of users currently inside the balances mapping of each user. Okay, the database core functionality when we use it following methods new. Okay, and add user, get user. The only remaining step is to implement each other method. Since we are working with generic type, we also need to correctly establish the requirements of T so it can be valid file to prefix value. The T should implement the copy rate since it is required for getting values from a file to 52D. Okay, all the values of a dictionary implement the file to 50 value. A generic type should do as well. To insert values, requiring all the values to be destructible. Okay, let's see. So what we are going to do is we are going to make this data type. Let's see. I think I can make this inside this one only. Okay, so struct user database is generic over T. There are two things: users amount, u64 balances, L252 dict T. Okay, trait user database trait T fn new. It returns a user database instance of user. Yeah. Okay, fn add user. It should implement. Okay, okay, now okay, implement key drop. Okay, ref self user database T muted data name felt 252 balance T fn get user T copy ref self user database T generic over T name felt 252 and it will return a T. It will return a T user's name. It will why it will return user's amount. Okay, one new type user database represents a type database's users. It is generic over the balances of the user, giving major flexibility over user or data type. Okay. Okay. Add user to insert user, get user. The only remaining step is to implement each of these methods on in user database trait. But since we are working with generic type, we also need to correctly establish the requirements of T so it can be valid File 252 value. Okay. The balance is of type T है. Okay. Hmm. Mm-hmm. Okay. Balance is not. Okay. All the values of generic type. Okay. You should implement the copy since it's required for getting values. Okay. All the. Okay. Mention value. It requires all the values type to be. Okay. Implementation. User database. Default file 252 dict value t of user database rate t. ये थोड़ा सा इम्प्लीमेंटेशन का इशू है. ओके. fn new fn new user database t user database. Okay, so this is a new database. Okay, users amount 0, balances default. Okay. Fn get user implement copy t ref t coffee t user database t name file 252 t. Okay. self balances get name. Okay. fn add user implement t drop t ref self user database t name L252 balances t dot balances dot insert name get user. This should not be add user get balance. It should be get balance name name comma balance. Self dot users dot mount plus equals to 1. Our database implementation is almost complete, except for one thing: the compiler doesn't know how to make a user database go out of scope since it doesn't implement the drop rate. Since it has a failed to remember, it cannot be dropped. So we are forced to implement the okay. Since we are it cannot be dropped. So we are forced to implement manually using drive destruct on top of the revision one because of the necessity in the struct application. Okay, let's see. Implement user database destruct. T comma implement T drop T default value T okay of destruct user database T and destruct self. After completing this, I'm going to raise a pull request to change this method name to get balance user database T. No panic. Self dot balances dot get squash. Okay, let's just run this. I just want to make sure there are no errors. Ah, there is some issue. Implement user database destruct T. Implement T drop. Implement T default. Fell to 52 value. T of destruct user database T. Okay. Fn destruct self user database T. No panic. Self dot balances dot squash. Huh. What it is saying that parameter type of information user database is still incompatible with affected missing. Ref parameter type of what it is saying that parameter type of uh, implementation user database destruct. Let's just okay, syntax wise is this correct? Okay, so type not found. Okay, type will not be found obviously because we haven't, you know, fn user db example. Okay, let mute db equals to user database rate new. Okay, db dot add user sim and rate. Okay. Mm, ah, silly me. Okay, let's remove the self. Hmm. What it is saying? There is some issue with this program. Let's see. So first we define the struct user database, users amount, and okay, 12 to 52 dictionary balances. Trait user database trait new user database. Yeah, this is wrong. User database. Yeah, I'm not sure why. Okay, drop user database name balance. Okay. T implement T default user database set. Okay, new. Okay, user database get name. Okay, okay, destruct. Okay, parameter type of implement function destruct is incompatible, so the destruct is okay, incompatible. Okay, user database destruct T implementation T drop T T default file to 52 value T of destruct user database T right fn destruct self dot balances dot squash. Hmm. Parameter type of implementation function destruct. Hmm. Okay. Okay. Uh, what is this issue? Hmm. Okay. Let's see. No, the issue is from the very top. No, yeah, this is not the issue. Okay. The issue is with this. Mm-hmm. Mm, ओके, लेकिन हाँ, struct, now if I copy everything, comment everything, right? Clear everything. Hmm. Okay, missing token, FN new, ठीक है. Hmm. Okay, so the issue is with hmm, okay, okay, FN new, okay, uh, new, FN get, FN user. Hmm. Type not found. Okay, type not found. Hmm. Hmm. Okay, missing token terminal comma. Okay, implementation user database implementation T implement T default failed to 52 day. Okay, so here it will come of user database straight T. Okay, hmm. FN new. Okay, user database FN. Okay, get user FN get add user. Okay. Hmm. और इधर भी डिस्ट्रक्ट. ओके, क्लियर टर्मिनल करो. ओके. हम्म. Cairo concepts cannot infiltrate T dot insert nullable from box. So this is a generic argument must be known. Destruct. Mm-hmm. Mm, Okay, actually, you know, yeah, level example, right? Okay, first generic argument must be no. Okay, so add user db dot add user Shivam 50. Okay, let imbalance db dot get user, let Shivam balance. Shivam. Okay, cannot infer trade drop by generic argument. Dictionaries dot Cairo. Okay, I mean, let's copy comment this. Okay, this is the issue. Build, build. Mm, mhm. Identifier, label example 11. Mm. User DB example. User DB example. User DB. Mm. Mm. Okay. Uh, mm. Canadian rate self dot balances dot insert. Okay. Okay. Mm. U size. Mm. Okay, let's see. Get user self dot balances dot insert t drop implement t drop t ref self user database name 12 to 52 balance type insert name and balance. Okay, self dot balances dot get name, that is also okay. T implement t default 12 to 52 u of user database trade t. Now this issue db.add user, we have get the new, okay, that not found. Can it not infiltrate drop? First generic argument must be known. Insert. Hmm. Self dot balances dot get and insert. What the heck, man? db dot get user Shivam. Ah, database user database. I hope user database. The issue will be might be with the spelling, right? Destruct user database. Okay. Okay. Hmm. Hmm. Okay. Might be the issue, right? Yeah, that was the issue. Damn, bro. Damn. Right? So damn. I mean, it was the spelling issue. Assert. Satyam balance. Equals to 100. Expected 100. Okay. And assert. Shivam 50. Expected. Hmm. Okay. Now the idea is basically to um, idea is to raise a book, raise a web3 Cairo book. Pull upstream. Nice. Update it. Okay. PCB pick slash dictionary example. So what I want to do is basically change the method name, and I'll raise. Okay, and I guess the uh let's just so I mean it's a good idea, yeah, to contribute in the open source. As soon as you find something, you can uh raise a pull request. Let's see to MD book. So okay, and I am going to find get user, or maybe Alex latest. Hmm. We found. Okay, So we just have to change here fn add user get balance. Okay, okay, get the balance. Hmm. Add a user. Okay, destruct. Okay, add balance, destruct, add balance. Okay, get balance, get balance. Let's see. Localhost 3000, right? Let's see if it looks good. Localhost 3000. Okay, dictionaries. Alex balance. Okay, why it is showing the. I guess I need to restart this. No, it's not changed. Why it's not changed? Okay, where is that project now? MD books of. Right. Uh, MD books of. MD books of. Okay. Yeah. Okay. Add user. Wait a minute. Get balance. Get balance. Hmm. Let's see. Okay. Okay. Get balance. We need to also users balance. Okay. Okay. Mm, listing. Okay. Chapter 02. Book Cairo SRC. Chapter 02. Installation. Data type function comments. dictionaries. Import okay, get balance, find users balance, get user, ठीक है, okay, 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 let's commit this. It's MSG. Fix dictionary struct member example. Let's go to Cairo book, GitHub. Okay, let's see. GitHub. My repositories, Cairo book. Compare and pull request. Dictionary struct member example. In dictionary struct member example for user database. Name. User and change get balance for intuitiveness. Intuitiveness. Readable request. Why? There is another. Okay. Chapter 2. Get user, get balance. That is okay. What is this? Self dot names dot write lib dot Cairo. Okay, let's. Okay. Okay. Why the merging is blocked? So this is into my book, right? I have the complete rights. Okay, it should just verify the program compilation and then it should. Let's see what checks it runs.
Install Cairo Verify. Okay, this is nice.
Aerobook GitHub. Let's see the GitHub. Oh, okay. 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 I guess it will just pass. Okay, guys. I mean, that's it. I'm tired. See you guys. See you tomorrow, or maybe, late at night. I'm trying to do as many streams as possible. Just this whole building out in public thing. So, yeah, looking forward to do more of those streams. Thank you.